in our DSL assignments. A double-ended queue, or called as DEQue in short, is a linear list in which additions and deletions may be made at either end. So we can do the addition at the both the ends and deletions at the both the ends. Obtain a data representation mapping a DEQue into a one-dimensional array. So we have to implement it using one-dimensional array. Write C++ program to simulate DEQue with functions to add and delete elements from either end of the DEQue. Okay, so that's the definition of the problem. All right, now let us come to understanding what is the DEQue. So we have learned that the queue is like this, okay, and it is a data structure of kind FIFO. That is, whatever is a first that comes into the queue will go out. That means if we add it, so we will add it from this end, this is called as a rear end, and we will delete it from this end, that is called as front end. Okay, so if we add it, so let's say we add in a queue, a person is added in a queue, and if we add another person, then that must go after this person. So this person, new person is added, then another person, like this. So this way we add the in the queue, and if you want to serve the queue or give the service, then this will be removed from the queue and it will be given the service. So this is a queue data structure, or it is called as a first in first out. But the difference between the queue and the DEQue is now D double-ended queue. It's a double, so it is DE. D stands for double, E stands for ended, and Q. So it's a double-ended queue. So it is like this. In this case, what is happening, that here we will have the ends will be the same. Now here in the front end, so this is a front end and this is the rear end. So we will do the addition in the rear end as well as deletion from the rear end. We will do addition in the front end as well as deletion from the front end. So this is what is a double-ended queue. Example could be anything. जसं लाईन मध्ये कोणीही घुसतं, तसला हा प्रकार आहे. म्हणजे फॉर एक्झाम्पल जनरली disciplined line is like this. That is, a person is standing here. The disciplined line is that the next person should stand after that person, isn't it? That is called as a disciplined line. Third person is standing after this line. But sometimes it happens that there are some situations in which someone has to be given the first priority, like woman first, sometimes like that. If, for example, this is a line for all, and let's say a old lady comes and something like that, and it has to be that lady has to be served, then you may, with the kindness, you give the place. Now you stand it here, and you will be served. All right, so that is what is added at the first, all right, front end. So that is, we have now, instead of adding the old person at the last, we have added it at the first, all right, so that they can be given service earlier. Similarly, it may happen that now here in this case we have added at the first as well as we have served it. We have served it means that we have deleted it, all right, so deleted it, so that is possible. Similarly, it may happen that this person is standing in a queue and it has found that it has got some other important work to be done before this service, let's say this service. Then what he does, he removes itself from the queue. He goes out of the queue, and he may give a reference that this is my number, okay, this is my, and I'll just come in just 5 to 6 minutes, and then I may come after that, like this. Somebody does like that. But here that person can go out, so that is, you can remove from the queue from this part also, all right. So that is what is the typical scenario where DEQue can be used. Okay, so sometimes the someone has to be given the first priority to be implemented or to be served, all right. So let us try to implement it with the help of array as a problem definition. but we will try to implement it with linked list first, because linked list implementation with the linked list is much easier than with the array. Okay, we will understand it with linked list first. So let's take, there are two pointers, that is front pointer and the rear pointer. Okay, both are initially null. So both are initially null. Now let's say a person comes for a service, and then a node is created with some value, let's say 5, whatever is the value of that node, and then this will point to nothing, that is null. So it will point to null, and here this will be now the front, as well as this will be a rear. So both front and rear is pointing to now this node. Now there will be 4 operations then. Which are 4 operations? The first operation will be add at the front, add at front, AF, or it is also called as NQ front. Second operation could be add at rear, that is also called as NQ rear. Third operation could be delete from front, DF, delete from front, or it is also called as DEQue. DEQue means remove from the queue. So delete front or DEQue front, and the last operation could be delete from rear. Okay, so these 4 operations we need to implement for the double-ended queue. So let us take the first operation, add at front. So a new node will be created, and new node will be created. Let's say the value, its value is 10. Then what you do, it has to be added before front, therefore it comes before front, and then this points to the front. And now front change, we have added at the front. So this front will now point to, instead of this, now it will point to this. So front is here, rear is here. Now let's take another operation to be implemented called as add at rear. Okay, so what we will do, we will create one more node, and that node will be created, and let's say the value is 15. So we have to add at the rear, so therefore rear now pointing to this, and rear now, instead of pointing to this, now rear will be here. Rear will be here. Now another operation that if you want to implement it, that is called as delete front. Okay, so delete fronts means that we have to delete 10, and now front will point to 5. So what we will do, we will make this pointing to any other pointer, let's say PTR. What we will do, front, first we will take this front to the next location. We will take front to the next location. So now front comes here, and then what we will do, we will delete the PTR, this. So if we delete it, so this will be deleted, and front is pointing to 5. Now let's say we want to add one more, that is add at front, let's say a new node to be added. Then what we will do, we will create a new node to be created. So new, and let's say the value is 12, and then what we have to do, so this must point to the front, and front will point to now this is all right. So this we can do it. Now let's do the operation delete rear. Okay, so if you want to do this operation delete rear, then what we have to do, we have to delete this 15, and then rear is now this rear. We have to make it like this. So now we have to come one back. How to come one back? So there is no any way by which I can come back. It is not a double pointer, or it is not double queue, doubly linked list. It's a singly linked list. Therefore, what we have to do, we have to traverse from front till the rear, and we have to keep track of its previous pointer. Okay, so we will traverse from front to rear, and we will keep track of the previous pointer. So this P will be now previous. So what we will do, so we will make P is equal to the rear. So this P will be now rear, and we will first of all we will not make it equal to rear. First of all we will delete rear. So we'll delete the rear, and then P is equal to rear. So now rear is pointing to this. All right. So this is how we can delete the last node. All right. So this is how we can implement it using linked list. All right. So let us try to implement it with the help of linked list. So we already have a code of singly linked list. Okay, so we will take the help of that code. Okay, so I'll open the project. So we already have done the singly linked list, and we also have done the queue, but that with the help of, is it with the help of linked list? Yes, it is with the help of linked list. So so we'll take this code. We'll take this code, copy, and we'll try to create new project. Just a minute, students. Okay, now let us try to understand this code, and then we will implement these 4 operations, double-ended queue. So class DEQue, that is double-ended queue, and we will take the only job time, no character job ID. So let us take only the integer, some kind of a value or a, some value a. Okay, just to implement it. And then we have a next pointer, that is DEQue pointer next, which will point to the next. Okay, so now we want 2 pointers, that is the front pointer and the rear pointer. So what we will do, we will make it a static DEQue pointer front pointer rear. Okay, because it is only one that is required. And what 4 operations we have it. Okay, so I'll write all these 4 operations. So which 4 operations we have? Let us take while. We'll continue with while 1, that is we'll implement the menu driven cout /n menu. So what menu will be there? /n 1 dot add from front, or it is also called as NQ front. It is also called as NQ front. Second operation is add from rear. It is also called as NQ rear. Next operation is delete from front. Okay, it is also called as DEQue front. Let's take another line because it is going that way. So what we'll do, I'll just take this on another line, just break it, complete this part, cout. Okay, /n 3 dot delete from front, then /n 4th operation is delete from rear, that is DEQue rear. Complete this. Fine. Now, and the last operation is /n 5 dot exit. Okay, so cout, enter your choice. So whatever is a choice, so we'll have integer choice. Now, so once it is done, so we'll have seen, we'll read the choice, scene choice. So switch choice. So first case 1. So it is enqueue front. So we'll write the function enqueue front, and we will call that function. Okay. So we will write down enqueue front. We need to create the object, new object we have to create it, and so one way of calling it is that with the help of new object. So case 1, so we have to create the new object obj is equal to new, and the class name is DEQue, new DEQue. So it will call a, if there is a constructor, it will call a constructor, but we are not writing any constructor, therefore it will not call a constructor. And then we will directly call the obj and the enqueue front. All right. Now the next is, let us break after this. Case 2. Case 2 is add from rear. So same thing, we will have to create one more object and just call a function. Instead of enqueue, now it front, it will be enqueue from rear. Okay, so rear will be there. Now the next case is case 3. Case 3 is delete from front. So we'll call directly the function obj delete front or DEQue front. DEQue front. Break. Case 4 we will call again let us have DEQue rear. Okay, and last case is case 5, it is exit. All right. So now we can have one more thing is a display queue. Okay, so we can have that display queue also. We will not add this function right now. We will, if required, we will add it. Okay. So now we have already defined the function enqueue front. So it is a enqueue front. So it returns nothing. It's a void. So we will ask to the user enter number, any number, and we will see in A that number, and then next is equal to, in this case next will be equal to the front. First of all, we will have to check it whether while adding enqueue in the front, if front is already null, if front that doesn't matter, if it is a null also, then there is no problem. Then next is equal to front, and what we have to do, front is equal to this. So now front is pointing to this, so there is no need to check it if front equal to null. So this code is not required. Even if it is null, then even if it is a first node, then the next is we have to make it null, so it will automatically point to null and front equal to this. Now if we have to now add into rear, void enqueue rear, right? enqueue rear. Now in this case, we will have the same cout enter number scene A, that will be there. So it will be there. Then what we have to do to add at the rear, we have to traverse, as it is told to you, we have to traverse till the rear, and then we have to no, for delete we have to do it. Oh, for adding it there is no need. For delete we have to traverse. For adding there is no need. So if this is a node, now it is a front as we have created it, so it is a front, and rear is now we have made it as a null because we have not assigned rear, so we have to assign it to rear also. So here what we have to do, we have to check it. Yes, it is necessary. If front equal to null, if it is a first node, then rear should point to, then rear is equal to this. It has to be done like that. Otherwise there is no need to do rear is equal to this, because rear will now point. Okay, if it is a first node, then rear must point to the current node. So that means right now we don't have any node, so both front and rear are null. So we created a node. So once we created a node, then F should point to this as well as R should point to this. That is what we are doing it. If front equal to null, then rear is equal to the current node. Rest this will be the same. Now enqueue rear scene A. So what we have to do? Rear ka next is equal to this, but we have to make next is equal to null for this current pointer, and rear ka next is equal to this, and rear is equal to what? Rear is equal to this. So what we are doing, let's say new node to be added at the end, then what we have, this is a rear, so rear ka next is equal to this, so this is a node, and rear is equal to this, so now rear is pointing to this. So that is what is done by these two statements. So enqueue rear is done properly. Now what we have to do, first of all we'll just now display, we will try to display it. We'll write the display function, void display. So to display it, we have to traverse from the front till the end, that is DEQue pointer ptr is equal to front, and while ptr not equal to null, we have to traverse. So what we have to print? Cout. So we have to draw a node kind of a structure. So this is a node followed by number, which is ptr a, followed by the closed structure this, and then followed by this. Okay, so that it will point to the next node, and ptr is equal to ptr ka next, so it is going to the next data. Now so last we have to print null, cout, because it is lastly it is pointing to null. Done. So we have done the display function also. So let us add one more function. 5 is /n 5 dot is display and slash n 6 dot is exit. 5 is display, so let us call obj display, and let us break it, and case 6 is the exit. All right. Now, so let us create the pointer, obj pointer. So DEQue pointer obj, object pointer. All right. So now we have successfully created. All right. So this is while is done. So we have to just now initialize this pointers. So since it is a static pointers, we have to initialize it with the syntax. All right. So the syntax is like this. So we have DEQue, sorry, static DEQue front equal to null, and static pointer DEQue, and it is a static pointer DEQue rear is equal to null. All right. So we have initialized init to null. Now, so let us run it. We have to choose the language. The language is, let me first copy. Copy. Select the language. It's a C++. Now it is giving the error NQ front in the DEQue function. What is the error? Display is completely done. DEQue is successfully done. Then class. So, done. Now here DEQue front. Acha, we have not written DEQue front, so I'll just comment out this. DEQue rear, comment out this. Okay. Now let us add from front 1. So number is 5. Let us again add from front 1. Let us add 6. Now let us display it. So we got 6 and then 5, then null. All right. So we have successfully now added. Now let us add at the rear. So add at the rear, let's say the number 10. Let us display it again. So 10 get added at the after 5. Okay. Now let us add again in the rear. Let us add 15, display it again. So 15 get added. Okay, so now we have successfully created the list in which additions are properly working. Now let us add again from front and add the number 20, and let us again display it. So now 20 got added at the front. The list is intact. All right. So now we are correct. So now what we will do? Now we will try to now DEQue operation. We'll try to implement DEQue operation. 6 exit /n, enter your choice. All right. Now let us remove the uncommented, and now what DEQue front, we have to implement DEQue front, void DEQue front. So to delete from front, what we have to do, we have to just take a new pointer just like this. Suppose I want to delete this, so what I'll do, I'll point this to another pointer PTR, let's say, then I'll shift F front to this, to the next node, and then I'll delete this. Otherwise, if I delete it, then my next pointer will be lost. If I delete first before moving to the next, if I delete it, so my this pointer will be lost. So I will not be able to track where to go. All right, so this will be lost. So to avoid it, first go to the next node. Okay, so let us do that. So DEQue pointer PTR is equal to front. Okay, front is equal to front ka next. So now front is pointing to the next node, and just delete the PTR, that is the pointer, and this print the message cout the node having value. So that value we have to store it integer, let's say integer value is equal to PTR ka A. So we have stored it, that value, and then we will print, using that we will print the value. So the node having value, value is successfully deleted. All right. So now DEQue front is successfully, we have deleted. Now we have to implement DEQue rear. So just copy it, Control V. So DEQue rear. Now in this case, what we have to do? We have to traverse. We have to traverse from the front till the rear, and we have to keep track of the previous node. So what I will do? So we will require this. So while PTR not or PTR ka next not equal to rear, till it is not rear. Next node is till it is not rear, we have to continue it. Okay, and PTR is equal to PTR ka next. So where PTR will stop? PTR will just stop one node before the rear, because if it is, let's say if we are having this list, this, okay, so this is pointing to this is pointing to this, and let's say this is null, and this is front, and this is rear. So right now PTR is pointing to the front, and till PTR connects not rear. So PTR will move to this. Is the next rear? No. So PTR will move ahead. Is the next rear? No. So PTR will move ahead. Is the PTR next rear? Yes. Then it will stop here. So PTR is now pointing to this last node. Okay, PTR is equal to PTR ka next. So what we have to do? Int value is equal to rear ka. So that we have to delete it. Okay, so that value we have to delete. So so what we have to do? Delete. We have to make PTR ka next is equal to null. We have to make it null because it is pointing to the rear. So we have to make this pointing to nothing, null. So this we have made it. PTR ka next is equal to null. then delete rear. So rear is now deleted, and then we have to have rear is equal to PTR. Now rear is pointing to the PTR. So this is deleted. Now rear is this. All right. So rear is equal to PTR. And then we can highlight the message that the node having the value is successfully deleted. All right. So DEQue rear is also successfully done. So let us remove it. Now, so let us call these functions, run it. So let us do add from front, value 5. Again do add from front, value 6. Let us display it, 5. So we got 6, 5. Now let us do add from rear, 2. Let us add 10. Again display. So we got 6, 5, 10. Now what we will do, we'll delete from front, all right, DEQue front. Okay, so 3. So 6 has to be deleted. So the node having value 6 is successfully deleted. So now let us display it. So we got 5 and 10. Now we will add one more. Okay, let us add at the rear, 2. Let us add 20. Again display it. So we got 5, 10, 20. Now delete from rear. Okay, so let us 4. So we see that the node having value 20 is successfully deleted. Let us display it, 5. So we got 5, 10. Again we delete it. Okay, delete from front, 1. No, sorry, add. We have done add. Okay, so let us add 6. So again display it. So 6 is added. Now delete from front, 3. 6 is deleted. Delete from front, 3. 5 is deleted. Again delete from front, 3. 10 is successfully deleted. Now we try to delete from anyone, front, rear, anything. What is the message that we get it? So now it has terminated. It has to give that the queue is empty, and it is not giving. So let us add that message. What if the queue is empty? DEQue front. Now if front equal to null, then what we have to highlight the message, cout the DEQue is empty. And if it is not empty, then go into else part. All right, then do this part. All right. Similarly, we have to do this also for rear. So for rear, if rear equal to null, the queue is empty, else delete the node. All right. Now let us run it. What is remaining? Line number 45. Else, okay, oh sorry, for else we have not completed it. So else, similarly DEQue rear else, have we finished it? No. Okay, so we have to add one more. So this, it is completed. Now it is okay. Okay, so now let us add from front number 5. If we display it, so it has 5 only, let us delete it, 3. So 5 successfully deleted, again try to delete it. So we see that the DEQue is empty. Now try to delete from rear, 4, and then, so this code is not required. All right, so the node having value is successfully, now what is a value? So value is rear ka A, so that value is successfully deleted. Now let us try with this code. Previous not declared, so we have to declare it. What is the previous? No, which line number? 60. Which are rear is equal to pref. Rear is equal to, it has to be pref. Sorry. So now run it. So 1, add from front, enter number 45. So let us display it 5. So 45. Now let us delete from rear 4. So the node having 45 successfully deleted. Now let us try to display 5. So the null, so the queue is empty. Okay. So now let us try to delete from front 3. The DEQue is empty. Now let us try to delete from rear 4. The queue is empty. Now we are successful. Now we have not tried with the delete from front when single node is there. Let us try it. 1 single node, that is 34. Let us display it. Now try to delete from front 1. No, sorry, 3. The node having 34 successfully deleted. Now let us try to display. Null, correct. Now again delete from front. It's empty. Now we are successful. So we are successful in implementing the DEQue. So this is what it is. That we have implemented the operations, that is NQ, that is add from front, add from rear, then display, delete from front, and delete from rear. All right. So I'll just give this